Hello.
Good morning, sir.
Is it audible?
Yes,
So now
sir.
it's audible.
Now it's audible, sir.
Good morning,
Okay.
sir.
Good morning. Hello. Is it audible now?
Yes, sir.
Yes, sir.
Yes, sir.
So what is this inferential statistic? Oliver,
Yes, sir.
what is this inferential statistics?
Sir, example of it can be chi-square test, t-test, and from that we can draw inference.
Okay. Basically, wherever there are two distinctions there. One is we are describing some data, so descriptive, and then we want to infer something from this data. Whenever we are estimating something, we are trying to infer something, then it is your inferential statistics. For example, are the two groups have different means is an inferential statistics. Okay. Suppose you want to find out or you want to estimate, let us say, mean income is an inferential statistics. Okay. So basically, these statistics are different. Test and statistics are different. So this is called inferential statistics. We'll revise very quickly. If I'm not audible, please let me know quickly. All right. Is it visible now? Am I audible?
Yes, sir.
So this is what we have discussed already. And what we do is from sample we infer about.
Sorry to disturb you, sir. Your voice is not coming properly.
Yes, sir.
Yes, sir. It is very low, sir.
Okay. Is it coming properly now?
Yes, sir.
Yes, sir.
All right. Okay. So we get data from the sample and then we try to infer about the population. It could be very simple, like what color people prefer. So you asked some sample you give them about, let us say, 7 colors you give them, and then ask them to choose which is their preferred color. And you do that for a sample of 100 people, and then based on that sample, you say, in general, which is the color preference of the population. Okay, so this is your inference. Okay, while we are inferring, because these estimates are not going to be correct. Okay, it cannot be. You can't say that okay, whatever I am inferring from the sample is 100% correct. That's not possible. So whatever inference you draw has some degree of you can say an error, or there is a probability, which is known as confidence level and significance level. It is something like you say confidence level, proportion of time that estimating procedure will be correct. Okay, so you say if something is, let us say, you say the income, mean income is 15,000 to 15,500, and this, whatever you have estimated, 15,000 to 15,500, is likely to be correct this percentage of the time. So that would be your confidence level. Okay. Similar is your significance level. So this is alpha 1 minus alpha, confidence level, and significance level is 1. We'll discuss this. We have discussed this. How to build an histogram. We have discussed. Stem and leaf plot. We have discussed. All right. Ozai, we have discussed. Time series data. As well, we have discussed. Chebyshev theorem we have discussed. What is the Chebyshev theorem is applicable to what kind of distribution?
Sir, distribution to all shapes of the histogram.
Say it again, please.
Sir, distribution to all shapes of histogram.
All?
All
Shapes.
shapes of histogram.
Yes, all shapes, not only the normal distribution. Okay, so
Yes,
Chebyshev. Then box plot we discussed. Okay, and this is whisker, first, second, third quartile. Okay, this is what we have discussed. What is this covariance? How do you normally understand this covariance in common language?
Sir, if there is any dependency between any two variables.
No, not correct. Anyone else? Yeah. Covariance equation you see and then interpret what it actually means.
So relationship between two variables. If the one changes, then the another could also can also change. If the one variable increases, the other also increases.
No, that's wrong. One variable increases, other variable increases means what? It can decrease also, no? Isn't it? Anyone? Just see the equation and tell me. What is happening in the covariance?
Sir, we are taking the average difference of the value of x or y from the mean value.
So, essentially what it means is how much a particular variable is moving from its mean position. Okay, x change from its mean position and y change from its mean. So when you notice that xi minus mu x, so this is the difference from the mean position. Is that clear? So this is the, are you able to see this equation?
Yes, sir.
So what it is talking of? With the product of the difference from the mean. Okay. Product of the difference from the mean. And we are finding out the average. So that means if x changes by 1 unit and y changes by 2 unit, okay, and what is there? Product of their differences. Is that clear? So this is your covariance. Covariance is the basic measure. We try to understand the group, and then what we do is all of this. For example, correlation. We try to understand in terms of covariance. Okay. So this is your correlation. Okay, and this is sigma xy, sigma x, sigma y. So this is sigma xy is the covariance. Okay, and we are dividing it by the sigma. We are making it normalized. Okay, are you able to understand what I'm saying? So if you notice, the first thing after, suppose we find something is normally distributed, we convert it to standard normal form by dividing it with the standard deviation. So similarly, when we are talking about population coefficient of correlation, we are dividing it by the standard deviation of the parameters. So that is our correlation. How does it help the covariance and correlation if you try to understand? What is the basic difference between the covariance and correlation? Anyone, please? Do we use covariance more or correlation more?
Correlation.
Why it is easier to understand, not covariance?
So because it describes the relation between the two variables, how it varies.
Covariance also is talking about that only. Or rather, if you see, correlation is derived from the covariance only. Sigma xy divided by sigma x into sigma y, isn't it? So what is the difference? Why we understand or try to understand the correlation more than the covariance? Anyone?
Correlation gives a strength of relationship between two variables, how far they are related.
Covariance doesn't do it. Anyone?
Covariance may vary from minus infinity to plus infinity, and correlation varies between -1 to +1.
That's correct. Yeah. You can compare the correlations, okay, much better than the covariance. Because if I say covariance is, let us say, 950, and in another case the covariance is 850, you can't really compare them. Okay. But if I say the correlation is 0.8 and in one case 0.75, then you know that the 0.75 correlation is little lesser compared to 0.8. So that is the difference. Are you able to understand this? Yes, no?
Yes, sir.
All right.
Yes, sir.
So that is the issue with the covariance and correlation. So this is we have already done. And if you see here, we are talking about x and y, and this is your correlation B1 we are talking of. Okay. Coefficient of determination. What is this coefficient of determination? How do we explain it? Quick. What is this coefficient of determination, please? Anyone? What it indicates? What does the coefficient of determination indicate, please?
It means that how much when one value changes, it can be explained by the changes of other values.
I did not, I couldn't hear it.
So it is when one variable changes, it can be explained by the changes of another related variable.
No, that is not coefficient of determination. Then you are saying the same thing, right? Have I lost? Hello, are you there?
Yes, sir.
Yes, sir. Sir.
If you are saying r and r square, okay, then r square is same as r. Is the meaning same? Coefficient of determination is r square, right?
Yes, sir.
And then r and r square meaning same. Yes. जल्दी करो.
No, sir.
So what is this coefficient of determination? What do you understand? Anyone, please? Yes, please. Am I audible? Hello?
Yes, sir.
Sir,
Yes, sir, but a lot of noise coming from your
A
side.
lot of background noises are coming, sir.
yes, sir.
There is some background noise which I cannot do anything about it. People are talking. I wish that will go away. They are discussing something. But go ahead, tell me what is this option of
Sir, its value lies between 0 and 1. The 1 means that the model, the calculation is a perfect fit, while 0 means that it fails to calculate the data.
no? I mean, whatever you have said is partially correct, but you don't understand what is that R square. Suppose R is 0.9. R square is how much?
Point and I correct.
0.81.
0.81.
0.81. So 0.9 means what and 0.81 means what? R is 0.9. So what it means? Coefficient of correlation is 0.9 and determination is 0.81. What it means? Try one more time. Please try one more time. Anyone? No? Say something. Hello? Am I audible?
Yes,
Yes.
sir. Yes, sir.
So you tell the answer, sir.
Yes, sir. Please tell the answer.
The correlation that you have derived, that is 0.9, is applicable to 81% of the data points. Are you able to understand this?
The correlation is on 0.9, right?
Ah,
So then how 81%?
that's what I will explain. Um, You see, this is what I'm drawing now. Okay, so let us say this is my X with my Y. Okay, so for each pay closer attention. So let us say this one. So these values are there. There are various values of X, and then for each values of X, there are different values of Y. So like this will be spread. Do you understand? Are you able to understand this? Do you think this will be for one value of X, there will be one value of Y?
No, sir.
So you can take this example as weight and height. So you go the height as, let us say this, you have taken X as the weight. Okay, so for a particular weight, you will have very different number of or different heights. Okay, but when you are trying to find out a relationship, you want to find out a relationship like this. Okay, you want X is Y is a function of X, and this is what you want to find out. However, please notice that when you find out this what do you call that straight line, you are talking about R. Okay, this is, you are talking about your correlation. But this correlation that you have identified is not explaining all the data points. So we have different data points here. It's not explaining all the data points. So to what extent or to what percentage of the data points are explained by this R? So this, my R is 0.9 and 0.9, but only 81% of the data, all these data points that you have, okay, is 81% is being explained by this equation. Understood this?
Yes, sir.
Yes, sir.
So basically what we are trying to say here is, though we have identified a correlation, this correlation that we have identified, only 81% of the data points are explained by this correlation. Another 19% is not explained by this equation. Is that clear?
Yes, sir.
Yes, sir.
Try to think about it. Yeah.
Sir, means these 81% of the data points lie on that line. Does that mean
Yes. Yes. Now, actually, what happens is, it will not be a exact line which will be lying on that. This R that you have identified, let's say Y is equal to mx plus c, you will do, right? So Rx, and then there will be a constant. But please understand, when we say this Rx, there will be a band of lines. Okay, so how it is actually happens is, my values are lying in a band. So this band that I have identified would be 81%. So all this equation would have some degree of error. Okay, now if you try to figure it out, this within this band only the 81% would lie.
and sir, how do we decide this band?
No, you don't decide. You don't decide. You don't decide based on your data, original data, that two dots that we identified. Okay, if we try to calculate this equation, okay, we will see that this R that you are saying, okay, this is a fixed one. But if you notice, let us say R is equal to 0.9. That you are trying to guess, but this will not be always 0.9. So in few of the cases, you will have 0.889. Okay, like that, there will be lot of lines here. Okay, so from that you estimate. Sorry, you estimate that this 0.9 that we are trying to evaluate is almost explaining 81% of the data points. Now, if somebody says, well, my R is 0. Let's say 8, then this is only explaining 64% of the data points. So if you are talking about larger R square, that means you are saying that you are including more number of data points. Okay. So you are not eliminating a large number of data points. Okay. थोड़ा थोड़ा समझ में आ रहा है?
Yes, sir.
All right. So basically, the point is, please try to understand that the point is that whatever you derive, analyze the equations and find out the equation, those are not 100% applicable. Okay, so there is some degree of error. So when you are estimating that, we are trying to explain through R square. Okay, so we'll talk about probability a little bit. You already know this, and it is based on the set theory. Please pay attention to this discussion now. Okay. Complement of an event. Basically, what it says, if event is A, then A complement is written like this, and this is PA plus PA complement C is equal to 1. So this is your total possibilities. Okay, and then we use it Venn diagram. And this P stands for probability. This is your joint probability, A intersection B. Okay. If there are three sets, okay, A, B, and C, what is A union B union C? What is the formula? Any idea? A union B union C is equal to how much?
So P of A plus P of B plus P of C.
P, yeah, that's fine. Just without saying P. A, B,
B plus C
A plus B plus C, yeah.
minus
Uh,
intersection of A and B minus intersection of probability of intersection of A and B, minus probability of intersection of B and C, minus probability of intersection of C and E, plus probability of intersection of A, B and C.
all right. Oliver, can you say this?
Yes, sir.
Tell me.
Sir,
A union C is equal to
sorry, A union?
B union C is equal to how much?
Sir, probability of A plus B plus C minus probability of AB minus probability of BC minus probability of AC plus probability of A, B and C.
Yeah.
Is the common A, B and C.
So this is your A, B, and C. Yeah. Do you understand why this is getting added or subtracted?
Yes, sir.
All right.
Yes, sir.
So you have basic understanding of that. I'll get into this. So this is yeah, joint probability that we talk of. So this is your joint probability. This is union that we have already discussed. Mutually exclusive, as there is nothing common between them. Okay. Now, please pay attention here. This is an example. Okay. What it says is, the example talks that there are students or there are MBA students from top 20 programs and not top 20 programs. And these MBAs manage the mutual fund operations. Okay. And mutual funds either will outperform the market or will not outperform the market. Is that clear?
Yes, sir.
Yes, sir.
All right. So now, what this table shows is if the mutual fund manager is from top 20 college, okay, and the possibility that the mutual fund will outperform the market is 0.11. Okay, that is about 11%. Is this clear? And even if the students are from top 20 business schools, there is a possibility that 0.29 it will not outperform the market. So like this, the table is prepared, and this one is showing 0.11 is what? The probability that the mutual fund manager is from the top 20 program and it outperforms the market. So if you notice that this is AND is written and this is your joint probability. Joint means union, sorry, intersection. Okay. So now if you notice, this all possibilities are included. So this is one. Okay. Both the and this then something called marginal probability. What is this marginal probability? Is suppose you are talking about given under certain condition, okay, if you consider all the possibilities, then it is your marginal probability. Okay, so what it means is given that A1, okay, that the fund manager is from top 20. So what is the probability of the fund manager becoming from the top 20? That is your 0.4. Okay, so this is your marginal probability. So you add across the row or the column. Okay, conditional probability. Conditional probability is given this, what is the possibility? So you take out this intersection and divide it by given condition B. Okay. How do you read it? Given B, what is the probability of A? Is your conditional probability. So, so you notice how it is happening is whatever is given, that will be in your denominator. Otherwise, the numerator will always have that joint probability, PA and B. Okay. So, now please look at this. So, what is this? Can somebody tell me what is this equation? Can you read this equation? Not the formula itself, but what it indicates. PB1 given A1 is equal to 0.275. What does it mean?
There is,
Try to understand the meaning. Yeah.
so there is 27.5% chance that the fund will outperform the market given given that the market graduated from the top 20 MBA programs.
So what we are trying to say here, notice what's happening. What is A1? A1 is the probability that the fund manager is from the top 20 colleges. Correct? What is that probability? That probability is 40%. Is this clear?
Yes, sir.
Yes, sir.
Alright. So now, given that probability, okay, what is the probability that the fund is outperforming? Fund outperforms is 0.11, okay, independently. But if we are trying to relate it to the probability of the fund manager is from the top 20 colleges, then we are saying 0.11 divided by 0.40. Okay, so that is equal to 0.275. What it means is if the fund manager, or given that the fund manager is from the top 20 MBA schools, then there is a 27.5% chance that the fund will outperform. And please notice, you can always also think that less than that is 100 minus 27.5, which is your 62.5% chances there that the fund will not outperform. Okay, so that is the use of this conditional probability. Independency is if there is no influence of the given condition. So how do you understand that there is no influence of the given condition? That PB that used to happen, you should have divided it by PB in this case, in the first case. So if it becomes PA independently, so this is independent. Okay. Yes. Any other question you would like to? I think I'll take the attendance now. Keep thinking and we will come back to this discussion. This is your section C, right? Yeah. Avinash Panda,
Present, sir.
Avinash Mahapatra, Avinash Patnaik.
Yes, sir.
What is this? Aditi,
Present, sir.
Aditya, Aditya Agarwal, Aditya Das, Aishwarya Apsita,
Present, sir.
Aliva, Alok,
Present, sir.
Alok, Alok, not there. Anirban,
Present, sir.
Anuradha,
Present, sir.
Mitra Gary, Arpan Mohanty,
Present, sir.
Arpan Moidar,
Present, sir.
Arpita Gupta, Arpita, Ashish Paikrai,
Present, sir.
Avik Chatterjee,
Yes, sir.
Ayush Samu, Banali,
Present, sir.
Bhaskar, Chandita, Chinmay, 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 Devasmita,
Present, sir.
Devapam,
Present, sir.
Dipsika,
Present, sir.
Gautami,
Present, sir.
Titisri,
Present, sir.
Jyoti,
Yes, sir.
Khushbu,
Present, sir.
Mahashwata,
Present, sir.
Mitali, Mitali Ghosh, Mosumi, Mosumi Shah, Neha Ghosh, Neha,
Present, sir. Present, sir.
Nirvik,
Yes, sir.
Pratyasha,
Present, sir.
Pratyush,
Yes, sir.
Prince,
Present, sir.
Priyanshu,
Present, sir.
Rahul,
Present, sir.
Rajeshwari,
Present, sir.
Rishabh,
Present, sir.
Ritu,
Present, sir.
Ronit,
Yes, sir.
Meenakshi,
Present, sir.
Sadeep,
Present, sir.
Sambit,
Present, sir.
Sambita,
Present, sir.
Santanu,
Yes, sir.
Simran,
Present, sir.
Sarda,
Present, sir.
Shivam, Shivam, Shreya,
Present, sir.
Shreya Shruti, Shruti Paul, Sneha Singh, Sneha, Soham,
Present, sir.
Somajit,
Yes, sir.
Saurabh, Saurabh विद्यार्थी, शुभजीत मुखर्जी, शुभजीत, शुभम विकास साहू, शुभम, शुभदीप,
Present, sir.
सुधांशु,
Present, sir.
सुनीत,
Present, sir.
तपन,
Present, sir.
तारिणी,
Yes, sir.
टाइनी,
Yes, sir.
कृषिता, यश,
Present, sir.
आदित्य,
Present, sir.
अभिनव, अभिनव सामंत, नेहा मुखर्जी,
Present, sir.
सेकंड क्लास होंगे, नीलाद्री, आदित्य दास,
Present, sir.
सलोनी,
Present, sir.
शिवानी,
Present, sir.
पीयूष,
Present, sir.
नित्यश्री,
Present, sir.
विद्याज्योति,
Present, sir.
स्वातिपन्ना,
Present, sir.
सिद्धांत आचार्य,
Present, sir.
अशोक,
Present, sir.
सोनाली,
Present, sir.
नमन, राजन, राजन शाह, डन। Thank you.
Sir,
Yes.
sir,
Yes.
Avinash Mahapatra 21202145, sir. Present.
Why you did not respond?
Sir, I raised the hand because mic was not starting, sir.
1.
2145, sir.
145. Okay, done. Thank you.
Thank you, sir.
All right.
Sir, 195.
I will not give you. Shivam Pradhana 195. 195. All right.
Thank you, sir.
Shivam, what is sorry? Oh, okay. What is your roll number? One four eight. Okay. Anyone else? Okay, done. Anything else you would like to understand? So this will form basically my part of your midterm evaluation or midterm question. And from here onwards, Manu sir will take it up, and then I will come back a little later. Um, Anything you would like to ask me? I mean, I'll upload this PPT. Okay.
Sir, can you please explain relation between variance and covariance, sir?
Variance and covariance. Okay. Now, all right. Basically, I'm recovering from my COVID, and still I have some bit of cough and this thing. So there is issue. Anyway, so let's see. Very basic understanding you should have. Those who are not interested can log off. I'm going to explain this very basic. Okay. Avinash, you have any question? You have raised your hand. Avinash, are you there? Should I throw him out? Okay. Okay. Remove. He's not there. चलो ठीक है. Okay. I'll only uh, I'll only explain this point very basic, and please do ask question. See, what is happening is we are talking about distribution. Okay, so you get a data set. Okay, and then what you do is you try to understand what is its distribution. Okay, so let us say you have taken three variables. Okay, and then you are trying to figure out its distribution. And for our purpose, we will assume almost a normal distribution. Okay, so you have this is your x, another distribution you have something called this is y. Let's assume that this is also normally distributed. And then I have another one, let us say, let's say another variable which is also somewhat normally distributed. This is my z, okay, x, y, z, and we want to see if there is some way we can find out some relationship or the way they are behaving in a particular situation. Okay. So the first step, this is once we have collected the data, we are trying to understand their distribution, and from this distribution, we want to do a comparison. So the first thing, again, what we try to do is to what do you call that, standard normal form. Okay. What is the standard normal form? Standard normal form is, you see, you have, say, mu1, and then standard deviation 1, mu2, and then you have standard deviation 2, and mu3, standard deviation 3. Okay. Now, if all these are different, we cannot really compare them. So what we do is, we make it a standard normal form. What does it mean? We mean to say that I would take, let's say, mu by standard deviation. Okay. Now notice that the z value that you are trying to get, okay, what is your z value? Z value is x
minus mu by
x
sigma. Minus mu by
minus
sigma.
minus mu by sigma. Okay, why we do this? Because we have that table that we have, okay, this is all for z. So for any kind of distribution, that means any normal distribution, okay, for each each normal distribution, we would require a z table. Okay, that is very confusing and cumbersome. So what we do is, all or any normal distribution, we convert it to a standard normal form. Okay, so we convert it to a it's not happening. We convert it to a standard normal form. Okay. What is the standard normal form? We just fit all the type of distribution to a standard normal form, and what it means is my mu is equal to, how much is my mu in a standard normal form? Hello? How much?
And P.
Huh?
Run into P.
N into P. No. Mu is equal to 0 and standard deviation is equal to 1. Understood?
Okay.
Is this clear? So that's what we say. This is my mu is equal to 0, and I convert it to my standard deviation as 1 unit. Okay, let's say like this. This is my standard normal form. Okay. Uh, Please understand that we are converting the normal distribution, all the normal distribution. For example, mu is, let's say, 5, my standard deviation is 0.2, my mu is 10, my standard deviation is 0.3. Whatever it is, we have to convert it to our standard normal form. Okay, basically a standardized situation. Okay, it is like whenever you measure a distance, how do you measure a distance?
SI unit. Okay.
Sorry.
Meter. In meters, sir.
So you find out, okay, this is my meter. So, and this meter I will compare any distance, and my, so one distance is 15 meters, so 15 times this particular value. Another distance is 10 meters, so 10 times this particular value. So basically you have to standardize. Is that clear? So how do you standardize the distributions? You have to also standardize, and this is what we do is standard normal form. Is this clear so far?
Yes, sir. Yes, sir.
All right. Now, having understood this, next question is, I want to understand what happens in my two variable situation. Okay, this is, I am talking about univariate. I have done my standard normalization, and now I would talk about how do I understand some relationship. Okay, let me give you, let us say if there are students randomly, I don't know who is who's good friend or a bad friend. Okay, let us say in your section, okay, let us say you are a good friend to somebody or not a good friend to somebody. Let's say there is a binary relationship. Please try to understand this. Oliver, are you there?
Yes, sir.
All right. Are you listening?
Yes, sir.
All right. So let me give you this example. We want to understand. In your section of about, let us say, 70 students, there are some students are good friends to some students. Okay. Some relationship exists, and we can observe that that same relationship doesn't exist with others. Let us say Oliva is a good friend to Sunit, but Oliva is not a good friend to, let's say, Prince. Okay. Understood this?
Yes, sir.
All right. So this is what we have to observe. Okay. So how we will observe it? What is your common understanding? Very common basic understanding. How will you observe that? What you will observe, and then you will say Oliva is a good friend to Sunit, but not a good friend to Prince. What will you understand?
So if Sunit asks for help and Aliva helps, then we will get to know that Aliva is a good friend, Sunit.
So all right. So this is one way of saying that. But it's a very difficult one to observe. Okay. Any other thing that you, let us say, same, you guys are moving, or I call everybody to a ground, and I leave you like that, and I observe you. And from that, I would try to figure out who is a good friend to whom and who is not a good friend to whom. What do I do? Do you understand, Anirban, the situation? I'm simplifying the situation because I cannot really observe if she is asking help and somebody is giving help. So I am not worried about that. So I call you to a ground, okay, a big football ground, and then I ask all of you to be there. So from that you interact or whatever you do, I will observe independently and say that these two are good friends or not. So what do I do?
So you will see that if Aliva is interacting with Sumit,
What do you mean by interact?
means they're having exchanging talk or exchanging something.
I am just observing. I cannot see from whether they are really talking or not.
They are standing together.
Yes. So please understand that the people with having some degree of affinity, higher degree of affinity, would be standing closer compared to others. Is that clear?
Okay, sir.
So now, if Oliva moves in a particular direction, and I understand Prince is moving in the same direction, I'll say, well, they are moving in the same direction. They have some degree of relationship. I find Oliva is moving in one direction. Sunit is not having some consistency with the movement of Oliva. Then I say, well, probably it is not like that. Do you understand what I'm saying? So if you take these Oliva, Sunit, Anirban, these are all variables. What I am trying to observe is how these variables are moving with respect to the other variable. Are you able to see this point?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So this movement, this coordinated movement or some relationship with movement, okay, is what we are going to understand in our, how we understand this. My measure is the distance, my measure is the standard deviation. So and I see how these are changing. So if Oliva is standing at a particular point and I say that is her mean position, and she goes north by 1 unit, okay, that means she is moving from her mean position to the north by 1 unit, and then I observe Prince has another position and moves to north by, let us say, 1.5 unit, and this movement is consistent. Then I say there is a covariance. Okay, but if let us say Bhaskar is not, when I measure this movement, Bhaskar is not showing anything. Either Bhaskar is not moving or moving in another some other direction, and it is not consistent. So I'll see that okay, the movement is almost indistinguishable or zero. If Bhaskar is not at all moving, that is zero. So that is what is my covariance then? Is zero. Is that clear? There is no movement.
Yes, sir.
Okay. So notice that this is the way basically we try to understand. Okay. If this is moving, that is moving. If this is moving in this direction 1 unit, that is moving in another direction 1 unit. And there is a the movement is some degree of repeatability, some degree of pattern is there. It is like if you try to separate and knotted, or there are a lot of knotted threads are there. Okay, there are many threads which has got knotted. Okay, So let us say 20 threads have got knotted, small piece of thread, okay, have got knotted, and you want to disentangle them. How do you do it? It's something like this, okay. So this is one. Then I have another one. Are you able to see this?
Yes, sir.
All these knotted threads have got knotted, okay. Now you have got one end of, let us say, X thread and another end of, let's say, Y thread, or some, this point is Y, and you want to establish if X is related to Y, or this is the same end of, or both the ends of same thread. So what you do is you pull it a little bit and observe if there is a corresponding moment with respect to Y. Is that clear? Now, if you pull X a little bit and there is a corresponding movement Y, and this movement is consistent, then you say, well, this is probably they are the same or the two ends of the same thread. But if another point is not at all moving, you see what? It is like, well, this is not. Is that clear? You can always let us say there are so many. Are you able to understand my example, or thoda confusion still?
No, sir. Yes, understandable, sir.
Understandable. Let me give you another simple example. Let's say there are so many. ये थोड़ा ड्रॉ करना मुश्किल है, but so you have a black box here, okay. You only know the legs and hands. So okay, there are so many legs here, okay, and there are persons are there, and it is a blanket covering them. So you don't know whose leg is this, and which is the person. They could be on any order. So what you do is you try to pull this leg, or pin this person, and then see this person is shouting, oh hello, that is my leg. Okay, so you pin this and you see this one is shouting. You pin this and you see this one is shouting. So it is like if one particular thing is moving, what is the other thing, how it is moving in a particular pattern or a direction. So then you say, well, this is my covariance. Understood this? Sigma xy. Sigma xy. What is happening? This is my x minus mu x, and then I try to figure out y minus mu y. Okay. Now, if x is this, there is a difference here, but this difference is not there. So you'll see that it is not related. Okay. The covariance, they do not vary together. Covariance means, if you are trying to understand in a common language, co-vary. So x and y, if there is a covariance, basically x and y co-vary. If there is a variation in x, there is a variation in y. So if in such a scenario, then we say there is some covariance. But suppose x you are changing, but there is no change in y. So covariance is 0. Y is not changing from its mean position. So you prick a leg, and this person is not showing any emotion. So there is no variation, okay, from its own normal position. So this is your x and y covariation. Okay. Yeah. Are you able to see this?
Yes, sir.
So this is what is the common understanding. You can use it for any purpose. For example, even let us say there are two wires, long wires. You want to find out whether say 10 wires are there, and you want to see the one wire. What is the end of these two wires? So you try to do a covariation. You change x a little bit and then you see whether the y is changing correspondingly. Then you say, observe that okay, they are related and then there is some degree of relationship, covary. Okay. If the covary is not happening, then you say there is no relationship. And in data sense, when we are taking data, we actually physically can't do it. But when you take this data, you can observe if there is some variation there. So how do you understand this variation? So you try to have this x is varying like this, and y is let's say y is varying like this. And then the principle of function comes for each x. So if you have x here, then your y is here, and your x is here, your y is here, and x is here, your y is here. So you find that for this change in x, there is some consistent change in y is happening. So you have a covariance. So you can say that there is some degree of relationship. And this degree of relationship, you are again, when you are standardizing, you are saying that, well, this is, I take it as rho, and then I say sigma xy divided by sigma x and sigma y. Okay. Now, if you notice, we did a standard normal form by saying mu by sigma or x minus mu by sigma. You can relate it here again. This xy is getting standardized with respect to x, and xy is getting standardized with respect to y. So if my x changes 1 unit, how much my covariance is changing? Or y changes 1 unit, how much is my covariance is changing? So this we call it a correlation or correlation. Understood?
Okay, sir.
Any questions so far? Did I explain your confusion or I confused you further?
No, sir. You are explaining. Sir, but then, so can I ask?
Yeah, go ahead.
So, but then we studied that finding correlation means correlation says correlation varies from -1 to 1, so it is better to find a correlation and the as compared to covariance.
Yes.
Sir, if in real life scenario, sir, when should we then use covariance and when should
Okay.
we use covariance?
Very good, very good. Yeah. So basically, what you are saying is, if correlation is easier to understand and all that, so why should we have this covariance and where it is used if it is not going to give us a clear-cut direction? Okay. Now, please understand the basic logic. Where from this basic logic is coming? Basic logic is coming from covariance. Understood?
Okay.
The correlation is a derivation of covariance. And the ab initio, initial basic logic is your covariance. What it means is, if I change x from its mean position by 1 unit, y changes from its mean position by how much unit? Very simple. Is that clear?
Yes.
Okay. So first is that the covariance is the basic unit of deriving any kind of relationship. Please be very clear about it. But there is a problem. What is the problem? Problem is its extent varies from minus infinity to plus infinity. So I cannot really compare between two sets of relationship. So what I do is I have to again bring it to some kind of normalization. Okay, it is something like this. Let's say, let me give you another example. Let's let us say this is your x. What happened? Yes. What is it? Yeah. Yeah. Okay. So this is my x, and this is my y. Okay. Now I have something here. Okay. And let you assume it is a ball or something, whatever. Okay. And this is my y. Okay. But now question is, this is my rest position of x. If I change x by some unit towards right, how much is my y changing? My y can change this big. My y can change a little bit. So like this. So what is happening is we are shifting x from its mean position differently and then observe how much y is changing. Is that clear? So now if I, let us say that there is a correspondence, it's 1 to 1. I change this by 1 unit, this changes by 1 unit. This is a different way, and somebody say, okay, towards right I change by 1 unit and towards left y changes by 1. This is again a different. But the whole problem is, or whole issue is, I'm changing x from its mean position and my y is changing from its mean position. Is it happening? That is my um, so I'm observing this. This is my first principle. Then I normalize them. Okay. What do I do to normalize? The distribution the distribution normalization I said. So to normalize again my sigma xy divided by sigma x, sigma y. So whatever you are talking about correlation and all, it is derived from your covariance. Okay. Now, question is where it is used if correlation is the whole thing. Correlation is not all sets of um, relationship between variables. There are many other relationship which uh, do not form only correlation. Okay. So how do you understand that? Wherever correlation you don't get, but you find some variations are there. In such cases, you find out covariance. Now notice that when you are talking about market risk, have you started reading all that? Market risk, beta, stock risk.
No, sir.
No, sir.
Your FM2 has not started. Hello?
So we
No,
have
sir.
semester CNA and CF.
How do you understand the risk of a stock? Let us say you want to understand how risky is investing in, let us say, Airtel in Indian stock market. What will you do?
We'll check beta, sir.
What is beta?
Beta.
Huh? गप्पो कौन है मुझे? Don't tell me stories. Huh? You tell me basic understanding. Let me stop this. Yeah. So what is this basic concept? Can anyone tell me what is this beta stock risk?
Change in price with respect to index price.
Very good. So what basically you are trying to understand is if my index moves 1 unit, how much the price of this stock is moving. Understood? So if my index is moving by 1 unit and the price of this stock is moving by 1 unit, then I do not have substantial difference in the risk. Come back to my example, covariance example. Okay. Now, here you may or may not be able to apply correlations. See, here you have to apply covariance. So if you notice that beta equation, you'll see that it is covariance. Okay. So if my stock market is falling by 1 unit, how much the stock is falling? Stock market goes up by 1 unit, how much my stock is going up? So if I am able to correspond a behavior, then I will talk about the risk of the stock. So covariance is used here, and if you notice beta equation derivation, if you just go through it, you'll realize that it is covariance. Very plain, simple covariance. Understood? And it is not correlation. Is that clear?
Yes, sir. Thank you, sir.
Thank you very much. We'll end the class here.